What's going on, everyone, and welcome to day number 6 of Learn Solidworks in 30 days. My name is Wong, and today we'll learn how to create a spring. By the end of this lesson, you'll learn the basics of how to select a spring, how to model a spring by using the SolidWorks Helix and Spiral tool, the 3D Sketch tool, convert entities, and finally, we'll learn how to use global variables to make dimensioning a lot easier. Let's go ahead and get started. First off, I'd like to show you one of my favorite websites, McMaster Car. Some of you may have heard of this website or have even bought items here before. McMaster Car is an American supplier of hardware, tools, raw materials, and various industrial equipment. They have a huge variety of different items you can choose from, and springs are one of them. I'd like to start by going to the search field and typing in springs to begin my search. Click on the first option to access the springs menu. You'll be presented with many different kinds of springs that you can choose from. Compression springs are the most common type of spring you will encounter, and they're typically used in the suspension system of your car, your retractable ballpoint pen, or the mattress that you sleep on. And then you have your extension springs, which are the opposite of compression springs, where it stretches from a rest state. Some examples of extension springs include trampolines, your garage door, medical devices, and so on. There are many different types of springs that are offered on this website, but today we're going to be focusing on creating compression springs. Now, when you click on this link, it's going to open up a catalog of various springs you can choose from. It looks like they have categorized this according to the length of the spring. Now, let's suppose that we need a spring that's about 4 inches in length. We'll scroll down to the part where it says 4LG. See this part where it says 4LG? The LG is short for length. And then there are these other options that we can choose from, like the OD, which is the outer diameter, DID, which is the inner diameter, the size of the wire, the compressed length at max load, the max load in pounds, and then spring rate in pounds per inch. If you're more of a visual person like me and want to know what the heck these numbers are talking about, McMaster Car has a drawing of the part that you can access by going into the product detail link. See this blue text that resembles a serial number at the second to last column? Now click on this, then click on this product detail link to open up a neat little visual of this part with its respective dimensions. It's a lot clearer once you have this drawing pulled up. This spring in particular has an outer diameter of 0.5 inches, has a length of 4 inches, a wire diameter of 0.063 inches. Now if you look to the right, you'll see that this particular spring has a spring rate of 8.73 pounds per inch. You might have heard of Hooke's law, where it simply tells you the relationship between the force applied to a spring and the resulting displacement. Hooke's law states that the amount of stretch or compression is directly proportional to the applied force. Now, what this means is, if I apply 8.73 pounds of force moving the spring an inch, you can expect that if I double the force at 17.46 pounds, you'll move the spring exactly 2 inches. So go ahead and select the spring that makes the most sense for your specific application. I'm going to show you how we can model this spring on SolidWorks. Alright, the first thing you want to do is you want to start a sketch on a plane of your choice. Go to the Command Manager and click on the Sketch tool. Click on the top plane for the spring. I'm going to be teaching you in a bit on how to use the helix and spiral tool, but before we get there, we'll first have to start a sketch. The helix and spiral tool uses a circle as a base. You can try sketching a random line and then launching the helix tool, but SolidWorks is likely going to give you an error. So we'll just delete this line and proceed to use the circle tool. Go ahead and click on the origin to begin a sketch, and then left-click again to place the circle. To create a helix, we will start with the circle tool. You may find it easier to pull up the drawing on a second monitor or printing it on a sheet of paper so that you can refer to the dimensions easily. For the sketch, we are going to pay very close attention to the dimension we give this helix. Do we dimension the circle according to the outer diameter, inner diameter, or neither? If you guess neither, great job. You'll want to dimension the circle at the midpoint of the outer and inner diameter, as you'll want to consider the thickness of the wire when you're doing a sweep later. The formula for finding the midpoint of two circles is by taking the dimension of the outer diameter and then subtracting it by the wire diameter. Also, did you know that SolidWorks allows you to input equations when placing a dimension like this? This is awesome as it cuts down on your brain work. Hit the green check mark when you're done. Once you have created the first circle, you are now ready to start creating a helix. Click on a sketch which you would like to create a helix with. Then head on to the Command Manager and click on the Features tab. Navigate to the curves icon, and then click on a small little drop-down arrow at the bottom. Click on the helix and spiral option to launch the tool. In a property manager on the left, SolidWorks will prompt you to define the helix by the following ways. There's pitch and revolution, or height and revolution, or height and pitch, or spiral. For this particular example, we're going to select height and revolution. For height, we will select a dimension of 4 inches. The number of revolutions are a little less straightforward since it's not mentioned on a drawing or the web page, but you can refer to the picture and count a number of revolutions. To save you some time, I've counted the number of revolutions to be 34. Make sure your start angle is 0, and then click on the green check mark when you're finished. With the helix created, you want to turn the skeleton outline into a sketch so that we can perform the sweep feature on it. To do this, head to the Command Manager once again and go to the Sketch tab. Click on a small drop-down menu beneath the Sketch tool, then click on 3D Sketch. With the 3D Sketch tool selected, click on a helix feature in the design tree, then click on the Convert Entities icon to convert this helix into a 3D sketch. Now that the helix is converted into a sketch, which we will then use later as a sweep path, we will go ahead and create a sweep profile right now. You may now exit out of the 3D sketch. Then select the right plane in the design tree and start a 2D sketch once more. We will use the circle tool again this time to create the spring wire. Rotate the model to where you can clearly see where the edge of the helix is, and then start a sketch of a circle that's closest to the start point. Next, we will then combine the two sketches together by first selecting the center point of the circle, and then holding down the Control key and selecting the start point of the helix. Once you have those 2 points selected, SolidWorks will show in a Property Manager the option to add a relation between the two sketches. You'll want to select a coincident relation to connect the two sketch entities together. This will allow you to properly perform a sweep feature later. If they're not connected together, you might run into errors as you're trying to do a sweep. We're going to go ahead and perform a sweep now. Exit the sketch, then click on the Features tab. In the last tutorial, I covered the basics of the sweep tool, so you might want to check that out to get a refresher. Click on the sweep tool. SolidWorks will prompt you to select a sweep profile and a sweep path. Open up the design tree on the right by clicking on a small drop-down arrow next to the Property Manager. The sweep profile will be the circle that you just created, which is sketch 7, and the sweep path will be the 3D sketch of the helix that you just created earlier. SolidWorks will then show you a preview of what a swept model will look like. You may zoom out and rotate the model around to get a sense of what a final product will look like before accepting the change. Once you're confident that everything looks good to go, you can go ahead and click the green check mark. Finally, we will link the height of the spring to a global variable so that we can adjust the height as we please. Global variables in SolidWorks are user-defined names that you can assign numerical values to. To access the Global Variables menu, click on the Tools option in the menu bar, and then click on the Equations option. To create a global variable, go ahead and type in height in the first field. Then assign a numerical value of 4 inches. Hit Enter to confirm your entry, then click OK to exit. We will assign a global variable to the height of the spring. You may want to adjust the view so that the entire length of the spring is visible to you. Go to the design tree and click on a helix feature. Upon clicking on it, you'll notice that the dimensions are displayed. Double-click on a 4-inch dimension that you see here beneath the spring. Then in the dimension field, type in the equal symbol, then type in height. There'll be a drop-down menu showing you the global variable that you just created. Click on the height option to confirm your selection. Then click on the green check mark to accept your changes. You have now assigned a global variable to the height of the spring. This allows you to change the height by simply assigning a different numerical value to the variable. Give it a try by going back to the Equations menu. Change the height to 5 inches, and then hit OK to confirm. Notice that the spring is now extended by 1 inch and measures 5 inches in the height now. The next thing I'd like to do is add the wire diameter as a global variable. I'm going to teach you another way you can add the global variable without going to the Equations menu. Right-click on the sketch profile in the Sweep feature and click on Edit Sketch. Click on the Smart Dimension feature and click on a circle to give it a dimension. Instead of inputting a value, you can instead type in a variable that you like to give this. For this example, I'm going to type in the equal symbol followed by wire underscore diameter and hit enter. SolidWorks will then ask you if you want to create a new global variable. Click on yes to confirm. Give this dimension 0.063 inches as shown on the drawing. Hit the green check mark to confirm your changes. Exit the sketch when you're done. Global variables can be a very powerful tool to use to make quick dimensional changes to one or more features in your design tree, and should be a part of your toolkit as you become a more seasoned designer. I really hope you got something out of this tutorial. This concludes day 6 of the series. Don't forget to tune in to the next episode, and we will see you soon.